Today we are going to discuss on the topic of merge sort, which is one of the most important technique in sorting methods. Merge sort, as it implies, we are going to perform the sorting operation by dividing and then merging concept. I am V. Uma Devi, working in Arunai Engineering College for the past 8 years in the Department of Computer Science and Engineering. Here I am going to give you a tech talk on sorting technique and specifically merge sort technique. Why do we go for sorting? Sorting is an important concept for making easy access of the data items. You have a collection of data items which need not be arranged. Okay. In order to have an easy access over a large collection of data items, it is better and it will be easy to access a particular data item if has been arranged in a specific order. Either it can be in an ascending order or in a descending order. For that purpose, we are making use of this sorting process. So, what is sorting? Sorting is the process or a method of arranging the data items in a specific order, that is either in an increasing order or in a decreasing order. There are various types of sorting algorithms which can be used for arranging the given data items. Among the various sorting techniques, what we are going to discuss here is the technique called merge sort. This merge sort was invented by John von Neumann in the early 1945 itself, and then it got extended and improved, and it is most widely used sorting technique in the field of computer science and engineering. Where it is getting used, if we see that merge sort has become the default sorting technique for various languages like Python, Perl, Linux kernel, Java. All these are a few examples languages which are going on still using this merge sort as their default sorting technique. Okay, how this merge sort is going to work? This merge sort is working on the strategy of divide and conquer strategy. Very important strategy, which is where the modularity concept gets involved. If we are given a complex problem, how to solve it? We employ modularity. Modularity means we divide the problem into smaller pieces. We finish the modules easily, and finally we merge all those modules to give the exact solution for the complex problem. The same way, the merge sort is also going to work in the modularity concept, that is, a given list of elements or set of elements is going to be divided into various sublists, and the sublist is getting sorted, and then we finally merge all the sublist and we go for it. Okay, so here in this presentation we are going to see these are all the objectives, or these are all the agendas, we can say. What is merge sort? We are going to say how does it work. We are going to explain the working principle with an example, and finally what are the two important pseudocodes or the algorithmic process which are involved in this merge sort, and how it is getting implemented in C. Okay, what is merge sort? Actually, merge sort is a comparison based sorting algorithm. Okay, merge sort is a comparison based sorting algorithm which is going to work, as I have already told you, it is working under the concept of divide and conquer strategy. Okay, so this divide and conquer strategy, as we have already discussed, is a very important strategy in the field of computer science because most of the algorithms works in the basis of this divide and conquer strategy in order to provide the solution in a very fast manner. And this merge sort, while it is performed, it is going to follow two types of properties. One is called not in place. Okay, merge sort is not in place, which means that while this merge sort algorithm is getting worked, it will make use of an additional memory storage space for performing its operation to be fully completed. Which means that if you give an array of elements, it will be using a temporary another array to make use of this process to be completed successfully. So we say that merge sort is a not in place property satisfying algorithm, whereas it is a satisfying stable property. What do you mean by stable property here? Is stable means the list of elements, whatever is there presented, all those elements as we give in the input, it will be always there present in your output also as such. Okay, so any elements will not be left out or it not will be added. More elements cannot be added or any elements which are given in the input, it is not getting reduced. Okay, and it appears in the same value. So this is what we call it a stable property. Merge sort satisfies stable property, whereas it will not satisfy the in place property. As I have already told you, in place means if you are going to have a memory space allocated for the given input list of elements, only that array will be used. That array means that memory storage space is being used for the entire algorithm to be completed. It is not so in a merge sort. It will use an auxiliary or an additional memory storage space in order to complete its process. The time complexity it takes is a constant of big O of n log n duration to complete its process. Now we will see how does it works. So it works with three steps: divide, conquer, and finally combine. That is, divide the array or the given list of elements into two halves recursively. Recursively means you have to divide the array of elements again and again. That is what we call it as recursive. So repeatedly sort left and right halves, finally merge the two halves so that it will give you a sorted list of elements. This is the basic principle. So the three simple steps you have to keep it in your mind is divide, conquer and combine. This is the basic principle being followed by your merge sort algorithm. Okay, so this is the stepwise I have given you how the merge sort process will be taking place. First, you have to select the entire array of elements whichever is given as an input for you. Split the selected array. Okay, so if it is even number of elements, it will be easy for us to divide it into two equal halves. After dividing the given input array into two halves, select the left sub-array. Again make a splitting process. Repeat the steps from 3 and 4. Again and again you go on splitting the elements. such that you will end up with only one element at the last, which indicates that further it cannot be splitted. So you have to go for the second step, that is called conquer, that is merging process. Okay, so after you arrive with the splitting of ending up with one single element, you go for merge. So merge from the seventh step, then the seventh step starts. Merge selected arrays back together in sorted order. Okay, so while you are sorting, that is, we have started from a top down approach, we go on with splitting. From the second step, we will go from bottom up process, merging and making it into a sorted array of elements. Okay, so while you are merging, you have to check it out, which is the minimum value, and sort it out. That is what is given in 8, 9 and 10. Select the minimum of the two values, add the selected value into the sorted array, repeat the process of 7 and 9 until we get the one sublist or the left sub-array is getting sorted out. Repeat the same process for the right sub-array also, so that you will end up with two sorted sublist, which should be given for the third step called combine process. Okay, so we will see a diagrammatic process of this merge sort with an example, so that it will be very clear with all these steps. Okay, so let us consider an example where we are given with 8 elements: 85, 24, 63, 45, 17, 31, 96 and 50. 8 elements are there presented. So now we have to sort these elements into an increasing order. Okay, I have considered an example that we are going to sort these elements based on merge sort strategy technique. We are going to apply this merge sort process for this 8 elements given, which are in an unsorted way, and we are going to make it into a sorted array of elements. Okay, now we'll apply the process. What does our process say? Select the entire array. So we have selected all the 8 elements. Now what is your second step says? Split the selected array. So now we have splitted it into two parts. Since 8 arrays are there, so you have to divide it into two steps, to sublist, which means you have to find out from which mid element. How will you find out the mid element? 8 elements, 8 plus 0 divided by 2, that is 4. So 0, 1, 2, 3 will be presented. You have to divide the entire list into two equal halves. 8 elements are there. So left 4 elements and right subarray contains 4 elements. Now select. What is your third step says? Select the left sub-array, split the selected array, repeat the process until you reach a single element. Okay, so splitter. Again you are splitting it into two. Now again you are splitting it. You have ended up with only one element. Okay, so what you have to do? You have to go for a second step. That is, we have to stop the split process. We have to go into the merge process. So now 24, only two elements are there. Now you have to perform the merge process. We have to select the minimum element from the given two list of elements. So what happens? 24, 85, right? And now we have merged it, sir. So first step, split, is a bottom top down process, whereas second step of your merge sort, which is supposed to be conquer or merge, is a bottom up process. So while you're going for a bottom up process in your merging step, you will be ended up with a sorted list of elements or sorted list of sub array elements. Okay, so this is also the same. You can view the steps from 1 to 10, which is getting represented in the form of diagrammatic representation here. So 63 single element. So no further splitting. You have to go for merging process. That's why the arrow gets reversed and it is pointed upwards. Okay, now it is sorted and after that it is given over here. Now you have to sublist. In this to sublist, again you have to perform a merge process. Merge means you are going to result in a sorted array of elements. Okay, so this steps from 1 to 10 which has taken place in the left sub-array, we have visualized it. The same will take place in the right sublist also, that is 17, 31, 96 and 50. Okay, so you are giving it over here, right sublist. The right sublist, again it will be performed in the same manner which we have seen in the left sublist, how it takes place, merge sort process. Now you have two sublists. Again, you will be combining these two sublists based on the merge process. So this merge process, after merging these two sublists, two ordered or two sorted sublists, you have to combine again and the final result what we get is a sorted array. Okay. So now we are looking over how the merge process takes place. This were the elements which were present previously: 24, 45, 64, 85, 85, 17, 31, 15, 96. Okay, so in your merge process, I have considered. Now we are explaining only the merge process. Okay, so your merge sort basically employs two types of functions. One is called split function, that is parting, and the second function which is getting used is merge function. Now we are going to see how the merge takes place. Merge. So 24. We are selecting the leftmost element which is present in the left sublist and the right sublist. Compare it and whichever is small, then store it in the final thing. So next 24 is here, 24 and 31 is compared and we get, so 24 is the least, so 24 is given to the temporary sorted array list. Okay, so 31 and 45, so 31 is supposed to be the smaller, so 31 will be there. So now 45 will be compared with 50 and so on. If we go on, this will be there presented in your merge process and finally you will get a result like this. This is what is taking place in the previous step. Okay, so what we get, this is the resulting array of informations. Now we will see the pseudo code. That is, I told you the two functions, main functions which are involved in your merge sort process is split and merge. Okay, so here is the pseudo code which is taking place for a split. So split, we are passing four elements as our parameters. Two are supposed to be arrays and third element will be the left index element and the right index element. We are going to implement an array implementation of your merge sort. So here, while you are splitting, we are passing four parameters, two arrays and two are declared as our variables left and right. Okay, if left is less than right, then, so what they are saying is you have to parameter, you have to pass an element over there. If left and the right is, if left is smaller than the right, then what we have to do, we have to find a mid element. What is that mid element? Left plus right, that is, we have already told you, if it is an indexing 0 plus 0, 1, 2, 3, 4, 5, 6, 7. Okay, so 8 elements you will be indexed with 7. So right most will be 7, left will be 0. 0 plus 7 divided by 2, which is 3.5. Take a lower bound of that, 3. So the mid is supposed to be the third element of your array. That is, A of 3 will be your mid element where you have to partition. Okay, so where you have to partition, that is A, T, and left is supposed to be your left element from 0, and the mid element, since it is the fourth element which is indexed by the array as 3, so till 3, 0, 1, 2, 3 index of your array will become one part, and the next part will be from the mid plus 1. Okay, so fourth element, fifth element, from the fifth element towards the last element till the right, you are going to represent this as another part. That is, the first sublist will be from left to the mid element, indicated by your formula mid is equal to left plus right divided by 2. Whatever you are getting as your mid element, till that mid element you will have one sublist, and from that next element after the mid, from there till the right, you will be considering as a right sublist. Okay, so after this will be going on splitting and splitting and splitting, and finally when we end up with one element, you cannot further divide it, and so we will enter into another function called merge function. Okay, so the merge function, what it is going to do is it is going to combine the elements, that is merge the elements in a sorted fashion. So in your merge function, you will be performing a bottom up process, and it will be going on sorted array of elements in your merge process. Whereas parting will not consider sorting process to be involved. Merge function will also perform a sorting of your sublist, divided sublist. Okay, so this is the pseudocode. Here we have declared, again we are going to pass 4 types of parameters for the merge function also. Two arrays. A of will indicate the actual array of elements. T of will be the auxiliary memory or the additional array storage space what we are going to allocate. And left and right are supposed to be the integers indicating the leftmost element and the rightmost element present in your array. Okay, so the process involves again right plus left divided by 2. I is equal to left, that is, I have told you, right? So this is left. J is equal to mid plus 1. What is mid? 85 is supposed to be your mid. What we got? 8 elements. 0 plus 8 by 2, which is equal to 4. So the fourth element is 85. So that becomes your mid. So mid plus 1 is 17. 17 and 24 is getting compared. 17 plus 24 is getting compared, and so if it is compared, whichever is the smallest, that will be given. That is, here if we take 24, A of 24 is less than or equal to A of J. J, what it indicates? J is 17. So 24 is less than or equal to 17. It is false. So what happens? It goes to the else part, and so you are getting T of target, that is in your target place, that is your leftmost is supposed to be indicated. Target left is assigned to your target. So T of target is equal to A of J. What is your A of J? A of J is supposed to be mid plus 1 index value, that is 17. 17 will be stored to the merge sorted array information. Okay, so this process will be going on. So if you get I value greater than mid, then you can understand that left sublist is getting completely sorted. If J is getting greater than the right value, then we can understand the right sublist have been completely sorted. So now again you go for the two sublist which has been provided after your merge process. Now the final two sublist has to be going in for the third step called combine process. So the combine process again it does merging and then finally it will be combined together. Okay, so this is what is happening in your merge sort process. Let us see, we have explained the pseudocode logic or the main logic in the form of a pseudocode. Let us implement these two functions in a C and we will see how your merge sort is getting worked out. Okay, right? Okay. The system is slight slow. Wait a minute. So if you want to work out in C, I have installed Turbo C in my system. So Turbo C, if you have installed, it will be there defaultly present in your C drive of your system. You have to go click on your C drive. In your C drive, C and select Turbo C. Then you have to click on with bin, and if you click on TC, your C window will get appear. Okay. So when you click on your Turbo C, your C window will get opened like this, where you have to type your C program. So the structure of your any C program is, first you have to include all your preprocessor directives. Then you have to declare the functions, whatever you are going to use in your programs. And then in your the main structure, you have to define it where you will call all the functions to perform the main operation. Here, as I have told you, I have written the program for your merge sort to take place. As we have seen, the merge sort involves two important functions called split or part and merge or conquer. So we have we have written the C program statement for the pseudocode what we have discussed previously. Okay, so I have written all the pseudocode information in the form of a C functions or C program statements. So after typing all your informations, so this is supposed to be your merge part. Okay, so the merge part, you have the array of elements, mid value, minimum value, and the maximum value. You have to pass on to your function. This is supposed to be the important function where you are going to merge the elements after performing sorting of the elements which are present in the sublist. Okay, so after typing all your program code in C, or after implementing the important merge sort functions part and merge functions, using that we have implemented your merge sort in C. So now you are going to check whether your program is right or wrong. Okay, Alt F9 if you give, it will show you if there is any error, it will show you errors over here. Then you can identify the errors with the what type of error is there present, clarify it or clear it out. There is no errors, just a warning which says you have to return a function, should return a value. Okay, so now to run the program, press Ctrl F9. So it will go to the output execution screen mode. Okay, so this is the sample which I have already executed. I have entered 4 elements. The array elements, entire array elements, 4 elements, 22, 44, 1, 34. So it has divided this into 2 halves, 22 and 44. That is, you have to find the mid value. Since 4 elements are there, 4 by 2. So the mid value is the second value. So 22, 44. So 22, 44 till the left to mid. Left element is 22, the mid value is 44. So 22, 44 will become one sublist, 1 and 34, mid plus 1 to till the right. So 1 and 34 will become another sublist. Perform the splitting operation. If you split the left subarray 22, 44, single element you have arrayed. So what you have to do, you have to go for the second step, that is merge. So when you merge, it will become 2244. The left sublist 2244, right sublist 134. Finally, merging of these two sublists will result in 122 34 44. Okay, so let us see another example also. If I am going to give 8 elements, let us say 9, 5, 8, 33, 2, 11. Okay, so if you see that we have given the entire list as 9, 5, 88, 33. This becomes one sublist. Another 2, 11, 8, 5 will be divided into another sublist, which is again and again entering into a splitting process till it gets on one element, and finally we enter into the second. And so the half sorted list, that is the left sublist sorted sublist, will be 5, 9, 33, 88. So now I have given 2 times 5. So all the elements, even if you give 2 elements, the same 2 number of elements, duplication if it is there also, it will be printed as such. So only we say the merge sort algorithm is a stable property satisfying algorithm. Okay, so whatever elements you have given, whether it is having duplication, it will also appear in the output also. This is what your stable property says. Okay, so this is the merge sorted list what we get after we implement or apply the merge sort algorithm process to be fully completed. Hope so you understood the merge sort concept and its implementation in C in a clear manner. Thank you.